Unit 18, Part 9. Okay, here's where we left off. We did universal instantiation on 3 to get this conditional. Okay, it's a conditional. The consequent is GA. We replaced X with A precisely because, well, at least one data point determining us was that here, if we replace X with A in particular, we have the negation of the consequent of that, which allows us to do a modus tollens. Okay, so moving on to here, okay, so here's steps 14 and 15, all right. I've done the modus tollens, right, so the result is the negation of the antecedent, right, so that moved the antecedent down there, was in the antecedent down here at 13 was in quantified form. Of course, the result of modus tollens, don't cheat, it is the negation of the antecedent, so it is a negation, not any longer in quantified form, right? But that's okay, I can transform that formula into quantified form, again by CQN, right? That's what? That's a negation of an A goes to O, right? Negation of A, universal inclusion, goes to O, particular exclusion. Note that the hook goes to dot, right? And we have this O form. Okay, so now here is really the crucial moment of matching, as it were, although we've been so very explicit about it that it's sort of straightforward from here. But look what we have now. Where is my attention? 15, I'm going to be existentially instantiating from 15, right? I've also got down here 12, so it's this one for all x. If y t's a, then a does not hy, right? Sorry, you can't see that. This one. We've got that, we're going to use that, okay? Can't see it. Anyway, yeah, you don't need that, so maybe you can, okay. That and that. Yeah, okay, there you go. We got this, we're going to use that, and we got this. Okay, we've got an existential and a universal, so just focusing on those two, it's focusing on the fact that we're going to be instantiating from both of them. What comes into play, the strategy point, the point of strategy, hard rule before easy rule, first application, do EI before UI, because EI is a flag rule, right? So you have to flag, so existential instantiation on 15, I'm doing the EI first, EI 15, so I'm replacing, why did I do that? That was a Y, sorry about that. That's a Y, it's existential Y, not X. It's HAY. Right, I transform from 14 to 15. I change the quantifier, but, sorry, I changed the quantifier from existential to a universal. I don't change the variable. Mistake, my bad. So it's there exists a Y, HAY and not ZAY. Okay, so now I'm existentially instantiating. I'm replacing the Y with what? Since I'm existentially instantiating, since it's a flag rule, I'm determined to flag B. Or at least I'm determined to not flag A. I'm not allowed to flag A because the flag letter has to be new to the proof. It's the first rule of flagging. And A has clearly appeared in the proof. A whole bunch, right? So it's going to be B. So I'm replacing Y with B. H, A, B, and not Z, A, B. Okay, look at that. These two relational predicates, the H and the Z, have now, from this formula, resolved both positions from variables into individual constants. Does it jibe? Does it fit well with where we're heading? Right, now working backwards, we got to here. ZAB, that's perfect, right? In fact, simplifying that, not ZAB, right? Simplify them both. 17 19, 18, right? Sim. Right. That's halfway home, right? That's exactly the formula we need. Yes, it very much jives with where we're heading, what we're aiming for, right? So it's very good that, right? So we were determined to replace that y with a b, determined by what? Determined by following the rules of existential instantiation. Determined by the fact that existential instantiation is a flag rule, and that flag letter has to be new to the proof. So in replacing that y, I cannot replace it with a, so I'm going to replace it with, well, the next letter down the road, which is b. So that's how that happened, that this came out as so. But even if I wasn't determined as so, I would have chosen b, right? Because I want ZAB in particular. Even if I was allowed to do not, I am allowed to do not ZAC, I don't want that, because that's not this. Not ZAC doesn't equal not ZAB. But even if I was allowed to do to A, to instantiate to A, to replace y with A, I wouldn't want to do that because not ZAA is not ZAB. Okay, now, here is really the crucial universal instantiation that you've got to resolve the choice properly. Really, it's sort of easy if you've gotten to this stage and you're doing it now, and you didn't do it earlier, right? Because everything else has fallen into place already. But what I'm doing now is, universally instantiating from 12, right? So I'm going to UI on 12. 12 starts with the x. I'm going to replace that x, but with what? Here I have a choice. I'm doing a universal instantiation. I can replace that x with an a, right? I'm being told that this propositional function is true of everything. So it's true of a. That's a legal universal instantiation. It's also true of b. But what do I want? Well, matching is what answers the question. Yes? Okay, so I'm going to get t something a, right? TAA or TAB. And I'm going to get not HA something, not HAA or not HAB. And it's clear, you will anticipate my words, what I want. I want, right, so let me just write this out to get 19, the result. I'm deleting the quantifier. T, we write it like this. T, why is that an X? God damn it! What should that be? Should that be Y? Yeah, that should be Y, right? What's CQN? Yeah, that should be Y for all Y. Sorry. That should be Y, of course. I'm stupid. So I'm replacing Y. Just making sure you're all paying attention. That's what I'm doing with these mistakes. It's on purpose. Right. That's why I CQ'd in from 11 to 12. I stupidly replaced the actual variable. Right. Supposed to do existential to universal, but not change the variable. Anyway, so we get T something A and hook not H A something, right? So question mark there, also question mark there and there. So this is the point you need. This is where you say, what letter do I want to replace my Y with? Right? What letter do I want to instantiate to? Again, the matching thought is what determines it, right? So you've got HAB here, right, which you could easily double negate, right, which I'm going to do in a moment. So, right, you should see that you have this available to you in the next step. So that could be, right, the negation of this conditional under the condition that this is B, of course, right? If it was not HAA, this would not be the negation, sorry, of the negation of the consequent. I meant to say, this has to be B for this to be the negation of the consequent. You don't have that yet, but you're looking at this and you're thinking, if I make the double negation, that could be the negation of this consequence so long as there's a B there. Okay, so that's one matching data point which tells you that this should be B. And what's the other one? Well, you're wanting to get, right, we already have this up here, tick, halfway home, tick, and home if I have this, okay? Well, what's this? It's T, B, A, right? So another reason why I want to replace my Y with a B, another data point. It's all about the matching. It's all about, you've got the X's and the Y's up here. A major question you should have in your mind in doing these is, when I come to replace those variables with individual constants in instantiating, which constant will I choose, A or B? How do I resolve it? You do the matching, which usually get a lot of information. And we got all, or at least sufficient information, by working backwards and getting the B, A, and the AB here. But there was also a lot of matching going on at the beginning, right? Because we had FA working backwards. We set up for a conditional proof. This FA is what made us choose A here, right? Especially since that got us to, and then that got us to GA, and so since we had those two, that's what made these ones A, or we said that. Anyway, it was also matching the one place predicates. Okay, and here, so we want this to be B, so we replace it with B, and you may anticipate, you should see ahead, that since we've got double negation to modus tollens, of course, the result of the modus tollens will be the negation of the antecedent. Hurrah! That's exactly not the A. So I get that negation, and so this is conch. Right? This is modus 21, 20, 21, 22, 23, 24, 25, 26. That's the end. Complete the annotation of your proof. Double negation 18, modus tollens. This 19 and 20, right? Modus tollens on these two. Conj of what? 17 and 21. De Morgan's 22. E.g. from 23. This is 24, 25, 26. Okay, and then CP, that's the conditional proof from something to 24. From 5 to 24. UG 25. All right. Here it is. Okay, I'll come back and do a model universe proof of invalidity.